Wait. Then, so we were learning this problem, that is calculation of R directly by taking variables as they are, and we saw this formula. And here this uh, type of problem or this sort of formula is being used in only two cases, that is if the values are very small. Okay, so if you see the value, they are single digit or maximum double digit. Even in double digits they are of less value. Or the other condition is, and where mean and standard deviation are not to be computed. You need not calculate mean and standard deviation for few of the problems because they are very very small. Because if you apply the deviation method, it is quite lengthy. You have to find the deviations, that is x minus x bar, and then apply the formula. So if at all your data is very very small, then you can understand that you are supposed to use this formula. Okay, now coming to the first question, x and y. So we are supposed to take the data directly from x and y. Now let us go to the tabular calculation. The heading which is compulsory is computation of Carl Pearson's correlation coefficient. We copied the problems from the question, that is x values and y values. Now after copying down these two values, we just have to total the values. Now first, seeing the formula, let us note down which are the important totals that we require. So firstly we require sigma x and sigma y. Then we require sigma x square, that is total of x square and total of y square. And lastly sigma xy. So keeping this checklist, let us find out the values. That is sigma x is 36, total of x. Okay, then sigma y, that is total of y is 18. Then x square, if you square all of these x values here, you get x square, and once you find them, total it. Okay, this is not x2, this is x square. Then similarly square all the y's. So what do you get? You get y square. Okay, so you get y square. So that is going to be sigma y square. It's not y2, it's again y square. So we found the value of total of x, total of y, total of x square, and total of y square. Then coming to xy, just multiply x into y. Okay, just multiply both the columns, you get xy, and then total of that, that is going to be sigma xy, which is 114. Clear? So this will be your tabulation, or this will be your tabular data. Now once we finish all this tabulation in the table, let us apply the values in the formula here. So the formula stands n into sigma xy minus sigma x into sigma y whole divided by square root of n into sigma x square minus sigma x the whole square. Here we are also supposed to know what is the value of n. N is nothing but the number of data that we have. So we have 1, 2, 3, 4, 5, 6. So 6 data we have which is given to us. So we'll take n is equal to 6. So R is equal to n is 6 sigma xy. What is the value of sigma xy? 114. Okay, so 114 is considered. Then minus sigma x into sigma y. So sigma x is 36, then sigma y is 18. So sigma x into sigma y whole divided by square root of value of n is 6 again, sigma x square. Sigma x square is 286. So 6 into 286 minus sigma x the whole square. Be very careful here, you might get confused. It is not x square, it is x whole square, which means 36 is sigma x. So square of that 36 you have to calculate. Then again, on for the y calculation, again the n is going to be 6. Sigma y square is 58. So 6 into 58 minus sigma y whole square. So sigma y is 18 whole square. For that sigma y you have to calculate. Okay, so that will be your next step. Now let us do the simplification. 6 into 114. 6 into 114 will give you 684 minus 36 into 18 is 648. You get 684 minus 648 whole divided by square root of 6 into 286 is 1716 minus 36 square is 1296. You have to do all this calculation. 36 square is nothing but 36 into 36. Okay, so once you find the value here, keep it as it is, then find the value for the y here. 6 into 58 is 348 minus 18 square is 324. Now in the next step, do the further simplification. First, subtract these two. 684 minus 648, you're supposed to subtract these two numbers. Let us see what is the answer we get. We get 36. Okay, 684 minus 648, we get 36. Then square root of 1716 minus 1296. See, here again, many students, what they try to do is, they will first try to find the square root of 1716 and 1296. Don't do that. Okay, first do the subtraction. First do the subtraction and you will get one number. That number you have to find the square root of. Okay, don't find the square root first and then do the subtraction. Sometimes you may get the right answer, but you will get confused. So first do the subtraction, which is supposed to be done for both of them. First do the subtraction and then find the square root. Okay, now after doing the subtraction, you get the values 420 and 24 in the denominator, and square roots separately for both of them. Both square roots are not same. Okay, separately you have to put the square root. Now in the next step, find the square root values. Now what are the square root values? Square root of 420 is 20.494 and square root of 24 is 4.899. Okay, so these are the values that we will get. In the next step, multiply these two, that is 20.494 into 4.899. So 36 divided by these two values, if you multiply, you get 100.399. And finally, 36 divided by 100.399, you get the value of correlation coefficient, that is nothing but 0.3586. Okay, 0.3586. So this is the value. Now we have to do the timeline analysis for every problem. This timeline analysis remains same. The method, everything. Now let us take this as +1, -1 and the value in the center to be 0. And we have other two values, one being 0.25 and other being 0.75. Now if you see, it is 0.35. 0.25 is here. Okay, so 0.35, let's say it might be somewhere here, 0.35, which just means that the values are ranging between 0.25 and 0.75. So in that case, and moreover, it is on to the lower side of the timeline. Okay, it is on to the lower side of the timeline. So you can say them as low moderate degree positive correlation. Okay, it is positive correlation because the value of R, okay, the value of R 0.3586 is positive in nature. So it is a positive correlation, but it is coming in between So it is moderate correlation, and it is coming towards the first half of 0.25. So it is low moderate degree positive correlation between, this is important again, between, which are the two types of data or two datas that we considered. One is X and other one is Y. So we have the low moderate degree positive correlation between X as well as Y. Okay, so this was the problem using direct formulas. Any doubts in this problem? Can we go for the next problem? Okay. Now moving on to the next problem. Again, in this also we'll be using the, we're going to use the same formula here also. So if you see here, calculate the coefficient of correlation from the following data. Now in this in this data, again, if you see, you have 400, 500, 600, 700, 800, 900 and 1000. But again, if you see why, they are simple data. Now you might ask, the numbers are in 3 digits, how do we consider? Now even though the numbers are in 3 digits, you will be able to bring it down or reduce it, right? You'll be able to bring it down or reduce it. So what we are trying to do here is, we will reduce the value of X and Y, so that it will become the simple data, very very simple data to calculate. Okay, so if you're able to do this easily, simplification of data, if you're able to do it easily, then it is well and good. You will also be able to get the answer easily. If you are not able to do that, if it's difficult and you are still thinking what is to be done, then in that case you will have to do it very carefully, or you will have to use the other normal method only, which you were using it before. Fine. So coming back to this, here for 400, 500, if you see, all of the data has two zeros in common. Okay, all data has two zeros in common. So I am gonna just remove two zeros from all of the data, and that all of the data is nothing but the value of X. So if you see the value of X, it is gonna be 4, 5, 6, 7, 8, 9 and 10. Okay, so how did I get that? 4, 2 zeros is taken. So X divided by 100. I divided the whole numbers by 100. So 400 by 100 is 4. Then 500 by 100 is 5, 600 by 100 is 6, 700 by 100 is 7, 800 by 100 is 8, 900 by 100 is 9, 1000 by 100 is 10. Okay, that is what you get here. So that will be your data for X. Now coming to data for Y. Y is nothing but, you can see the common value or common is 0. Okay, 1 0 you can take it out, which means you can divide the values of Y by 100, sorry, 10. Here it was 100 and this is for 10. Now here when you divide it by 10, 20 by 10 is 2, 50 by 10 is 5, 40 by 10 is 4, 30 by 10 is 3, 40 by 10 is again 4, 50 by 10 is again 5, and 60 by 10 is again 6. So we got the values to be very very simple and single digit. Okay, now let us do the calculation, and for summation of X, Y, X square, Y square and XY. So summation of X is, you add all the values of X, that will be 49. If you add all the values of Y, that's going to be 29. And then once we get the values until here, now the next step we can continue. Okay, then the next step is finding the squares. So x square and y square you're supposed to calculate. Now x square is multiplying the number with itself. So 4 4s are 16, 5 5s are 25, 6 6 are 36. Like this, you have to multiply the number with itself so that you can calculate the squares. Next, y square. Y square is again multiplying the number by itself of y. So 2 square is 4, 5 square is 25, 4 square is 16, 3 square is 9, 4 square is 16, 5 square is 25 and 6 square is 36. So these are the total values. Now once we had found out the values, that is x, y, x square, y square, the last type of value that is that we are supposed to find is x and y. Now this can be found by multiplying two of the columns, that is x as well as y. So if you see x here, 4 2s are 8, 5 5s are 25, 6 4s are 24, 7 3s are 21, 8 4s are 32, 9 5s are 45, 10 6s are 60. Okay, so if I multiply these two numbers, I get the values of x and y which I have written here. Now once I write and I total them, I get the total value of sigma xy, that is 215. Okay, so we have got all the 5 totals that is required to calculate the formula. Okay, any doubts in the table calculations? Are you all able to follow? Good. Then let us go to the formula quickly. Now, one more thing. In this subject, please write formula for every question or every solution that you solve. It is applied even in exams. Okay, without formula, they can cut 1 to 2 marks in your examinations also. You have to write formula for every problem. Now, R is equal to n into sigma xy minus sigma x into sigma y whole divided by square root of n into sigma x square minus sigma x whole square, again into square root of n into sigma xy square minus sigma y whole square. So n, what is the value of n? Now if you see the data here, 1, 2, 3, 4, 5, 6, 7. So 7 is the value of n in this question. So 7 into 215, that is sigma xy is 215. Then sigma x into sigma y, that is 49 into 29 whole divided by square root of n, value of n is again 7 into sigma x square is 371 minus sigma x. What is sigma x? 49. Okay, so sigma x is 49 square. Then into square root of 7 into 131 minus sigma y is 29 and square of that. Now, if you do the simplification, 7 into 215 is 1505 minus 49 into 29 is 1421. Okay, whole divided by square root of 2597 minus 2401. How am I getting all these values? If you see here, 7 into 371 is 2597 and then 49 square is 2401. This minus will remain as it is. Okay, now moving further for the y values, 7 into 131 is 917, 29 square is 841. Next step, 1505 minus 1421 will give me 84 whole divided by 196, square root of 196 into square root of 76. So that is the next value, square root of 196 into square root of 176. Next, 84 divided by, now 196, square root of 196 is 14 into square root of 76 is 8.72. Okay, 8.72. Now again, if you see here, first subtraction was done and then for the final value, we have found out the square root. So 84 by 122.049 will give me the correlation coefficient of 0.688. Now, once I get the value of correlation coefficient, my next step is to calculate or analyze this correlation coefficient using the timeline. Now, in timeline, if this is +1 and -1 and the value in the center to be 0, and I have two other boundary values which is 0.25 and 0.75. Let us see where the value will be placed. Now, if you see the value, it is 0.688. So 0.688 it is towards 0.75. So let's say it is somewhere here, 0.688. Okay, the point is somewhere here. Fine. It is positive correlation. It is positive correlation because the value here is positive. But it is still between 0.25 and 0.75. Since it is between these values, we are supposed to consider it to be moderate degree of positive correlation. Okay. Understood the analysis? Any doubts still here? Can we go to the next type of problem? Okay. Now, listen carefully. Next, calculation of Pearson's coefficient of correlation using assumed mean. So, we were supposed to find out Pearson's correlation coefficient using two methods. The first method was actual mean, where we used to calculate the arithmetic mean in the problem, take the deviations, and then we were doing or solving for R, that is correlation coefficient. Now we are going to do the second method, that is finding the correlation coefficient using assumed mean. Now first let us understand how to solve the problem, and then in the next class we can start with the problem. But this understanding of basics is very important, so concentrate. When actual mean of any given variables is in fractions. So when are we going to use this method? Whenever you get the actual mean in fractions, which is nothing but if you get any point. If you're not getting a whole number, instead of getting 36, if you get 36.758, don't round it off. Okay, when if at all you get points in your actual mean, then what do we do? The calculation of correlation coefficient using actual mean becomes tedious. Tedious means difficult, and involves calculations requiring more time. So it takes lot of time. It eats away a lot of your time when you're doing this problems, and when the actual mean is in fractions or decimals. Okay, in such cases correlation coefficient can be computed by using the assumed mean of the given series. So if you remember, we had solved in the previous semester the assumed mean problems. So we assume one of the number to be mean from the data itself, and then we will solve the problem, right? Similarly here also, apart from actual mean, we have to assume one of the data to be assumed mean. Then the coefficient of correlation is calculated using. So if at all we do the assumption like that, then in that case, which is the formula? Okay, so we have two versions of the same formula given. So let us see them. So first it says R is equal to n into sigma dx and dy. We will learn what is this dx and dy and everything. Whenever you see a d, it is known as deviations. Okay, it's known as deviations. So n into sigma dx. So summation of dx dy. Now in the actual data, if you remember, the previous whatever problems we solved, okay, so what was the formula there? N into sigma xy minus sigma x into sigma y whole divided by square root of n into sigma x minus, sorry, sigma x square minus sigma x the whole square, again square root of sigma y square minus sigma y the whole square. This was the formula, correct? Yes. So in all the place of x and y, I am going to replace it with dx and dy. That's all I'm doing. Okay, so the first formula, n into sigma dx and dy. So if you see here x and y, in this place I'm writing dx and dy. Then minus sigma dx into sigma dy whole divided by square root of n into sigma dx square minus sigma dx into whole square, and again n into sigma dy square minus sigma dy the whole square. Okay, so this is one version of the formula. This is one version of the formula. Now this formula can also be written in another form. Now let us see what is that another form. In this form,